is great, but in all honesty, when you gamble in Vegas with dice, you usually use 2, if not more than 2. We'll have to go, I think we'll hold the 3 dice game for next time, because I want to use the coin too that you guys got. So first off, what I want to do is I want to build the distribution like we did for a single die, but this experiment is, let's understand, experiment number 2. Let's roll 2 dice. Let's roll 2 dice, and let's keep track of the distribution of probabilities around that, rather than 1. 1 die, we took a look at it, we figured out it was uniform, all the probabilities are the same, 1 6, 1 6, 1 6, 1 6. As Lauren said, 1 6 chance of rolling 3, that means 5 6 chances of not. Good, good. Let's see how that applies over when we start putting dice together. So let's start with our template, x equals, now we'll talk about the sum. Let's talk about the sum. So when you throw dice, very often you want to be looking at the numbers that the dice add up to. Yeah, like 1 and 5 is a 6, 6 and 3 is a 9. You're interested in that. My son and I play Monopoly with my wife, and he knows right where he has to land and bankrupt me on Boardwalk with his damn hotels. He's like, well, Dad, if you roll a 5 or a 7. He's like, okay, great. And he's also learned, well, anyway, he's learned a little bit about this distribution based on how I react to it, and how much I'm quivering as I turn that corner. So he's starting to get a gut feeling about this. But let's do one thing at a time. What values? I know these are random variables, as Natasha pointed out. We don't know what's coming at any given time, which is why I sweat around that corner in Monopoly green-blue streak. But we do know the values you can get when you throw those dice, yes? Yeah. And what are they?
2 to 12.
Beautiful! We know it's 2 through 12. Those are the additive values. And somebody last time, I forget who it was, that they brought up, wait a minute, this is all based on the fact that dice have 1 through 6 on them. Absolutely! You can start futzing with those numbers. I mean, you can take a drill and a white marker, or a black pen, and you can start putting little dots on the dice yourself and coloring them in different colors, and you change the sums. All you gotta do is take that 1 and make it a 2. And then that'll change the values of the random variables, and it'll also change probabilities. But these are fair, these are usual, whatever, Vegas dice we'll call them. Cool? Alright. What should we put in the P of X column? What do you think?
How many times you roll that sum?
That's exactly right. So what do you think we should do?
Roll.
Roll. Good! Good, start rolling them. Keep track of what you get, if you would.
How many times?
Roll them enough to get an idea. Just roll them like maybe 5 or 6 times each, and write down the sums you get, like kind of in your notebook.
Wait, that won't be enough. We're rolling like 5 or 6 times.
If you just roll 5 or 6, and put it all together, you get 100 there. Yeah. Where's it gonna take us?
Snake eyes.
If you have snake eyes, there we go. So that's 2. Let me ask you a question while you're rolling. If you had to assign right now percentages to these, what would you do? If you had to throw percentages, remember how we had a single die, it was 1 6, 1 6, 1 6, 1 6, 1 6. So Sarah goes 1 12. Ooh, can I make it 1 11th instead? Because there's actually 11 sums. So make it 1 11th. Let me put it in a different color. So 1 11, 1 11, all the way down. Now that works from a sum point of view, correct? That adds up to 100%. Austin, did you say?
No.
Austin says no. Damn. He didn't mean Sarah. He didn't mean that.
There's more than one way to get a 3 or 11.
Hence why you're doing the experiment. I love this. Hence why you're doing the experiment. The question is, if we knew how many ways there were to get certain sums, we would know what these probabilities are. It's not as straightforward as a single die. A single die, you simply turn the dice over in your hands, 1, 2, 3, 6 outcomes, all of which are likely it's 1 and 6. If we say these are 1 and 11, which is about 9% each, that means we should be getting snake eyes 9% of the time, we should be getting 3s 9% of the time, we should be getting 4s 9% of the time.
Wouldn't it be the same for all of them?
What did you say? Wouldn't it be the same?
No.
So it would not be the same.
I don't know.
Good. That was like 3 statements in one. Thank you.
I'm just saying it doesn't make sense to me that there's not the same. I'm gonna get 3 couple different ways and 6 maybe only 1. Or I don't know.
This kind of agrees with Austin, what he was saying over
here.
here. So here's the deal. What I want you to do now is, this is a real quick informal roll you guys were just doing. I want you to use the dice more scientifically in a moment. Raise your hand raise your hand if you got snake eyes, and show me with the number of fingers on that hand how many times you got snake eyes. So let's just do a real quick count while you guys are rolling out. 4, 5, 6, 7, 8. You got 8 snake eyes. How about 3? How many got a sum of 3? A sum of 3. Okay, a few more there. We got like 8, 10, 12, 14. 14 of those. How about sum of 4? Sum of 4. Sum of 4. So we got like 7, 8, 9, 14, a few more, 18, in the 20s now, low 20s. So we went from 8 to 14 to low 20s. 5s. 5s, okay. I'm seeing more fingers each time. Interesting. So I think we can rule out this. Because this is not looking like it matches what's actually happening. How about 7s? How many 7s? Some of us need 2 hands now to report this, yes. Awful lot of 7s. We're going to jump right to boxcars, which is double 6s. Double 6s, sum of 12. Now look at that. Sum of 12 looks almost... I thought you got that many for that one. It can happen, of course, just like 5 3s in a row can happen. It can happen, just not expecting it to happen. I'm sorry, the boxcars double 6s? Interesting, very, very few. So what looks like it's going on is actually not this uniform. When you had the single die, it was a uniform 1 6 1 6 1 6. So this doesn't look like it's panning out very well. So my question is, if that's not the probabilities that should be assigned, what should be assigned? How likely is it that we get, for example, snake eyes? Caitlin, what are you thinking?
I was thinking, okay, so there's really only one way you can roll a 2, but with 2 dice you can have 1 and 1, and that's it for a 2.
Everybody, hold that thought. Everybody make snake eyes with your dice. I want to come back to you. I didn't want to cut you off, Caitlin, but I want to make this experimental too. I love what you're saying. Everybody make snake eyes? Can you make it another way?
No.
No.
That's it, right? You're done. Caitlin, continue. Thank you.
But if you're wanting to make a 5, you can have, or a 6, you can have 2 3s for a 6, or you can have a 4 and a 2 for a 6.
Okay.
There's different ways to make it.
I'll tell you what. Why don't we go through the entire shebang like Caitlin's saying? There's one way to make snake eyes, yes? I put out of something. Let's leave the out of something blank for a moment. We'll come back to that. Because it might not be obvious what the out of is right now. Once we have the out of, we'll know what the percentage is. But the out of might not be inherently obvious right now. So, everybody make 3 with your dice. Make 3 with your dice. I played 2.
Well, they're back here.
Oh, they're back. Oh, it's good. You got them. You just make 3 with your dice. Okay, thank you. Okay, you made 3? Make 3 again.
Go here.
Oh.
You only do that.
Now, I love this back here. Check it out. Everybody made 3, yes? 1 and 2? When I said make 3 again, I heard a couple of voices go, you can't make 3
Well, you
again.
can swap the dice.
But you can. This is why I made you use 2 different colors of dice. Right now, I've got a white 1 and a red 2. Is it white 2 and red 1 a different 3? I had to turn... Now, this is like, I don't buy that. But you have to, though. The dice moved, which means that's another way of getting 3. We couldn't do that with snake eyes, though, could we? If you have red 1, white 1, you can't go... It's the same 1 and 1. But when it's mismatched, the 1 and 2, if it's red 1, white 2, you can actually move the dice to make white 1 and red 2. That's actually 2 outcomes. Can you make another 3, or is that it? That's it, right? 1 and 2, 2 and 1? Good. So 3 is twice as likely, which actually syncs up pretty perfectly with what we saw in hands, right? In hands, we saw about 8 snake eyes and about 14 3s. Roughly double. Good. If we were slick and we had a larger sample, as Natasha pointed out, it's probably not big enough to do what I'm about to do. We could figure out what the denominator has to be right now, but we're going to get to it indirectly. Lauren? Are you sure? I doubt it. I doubt it's stupid.
Nope. I got it.
Well, think about it. If you want to ask it, please consider.
Alright.
Make 4!
3. You're
Three
3 ways.
Make 4. Oh, okay.
We're away ahead of you.
You're way ahead of me. You guys are very, very quick. Good. So there's 3 ways to make it. What are they?
2 and 2.
2 and 2.
1 and 3
1
and
and
1.
1 and 3, 3 and 1. Why don't we count 2 and 2 twice?
Because they're, yeah.
Because it's the same thing as snake eyes. 2 and 2 is 2 and 2. If you're playing craps, it's called rolling that sum the hard way. If you want to bet on 4 the hard way, you have to roll 2 and 2. The payout is much larger than rolling just 4 in general.
6 and 1.
But it's also harder to get, because there's only one way of getting 4 the hard way. So rolling 4 the hard way is the same as rolling snake eyes. It's 1 out of
That's dropping
blah.
that.
But rolling 4 in general, there are 3 ways of doing that, yes? Good! How about 5? You guys are already figuring this out, aren't you? Yeah, it's 2 and 3, 3 and 2, 4 and 1, 1 and 5, 1 and 4, 1 and 4, sorry. Can't add right now. So this is 4 out of
Drop that, yes.
6. Good. You'll notice all the even numbers have an odd numerator, and that's because all the even sums have a doubles possibility. Double 1s, double 2s, double 3s, double 4s. So you always have an odd numerator in those because of that. Good. This is going to be 5 out of something. This is confusing. I'm just going to put here. I'll make these smaller because I'm sort of space. Out of. We're at 6s now, yes? No, we're at 7s. Crap, I'm offline. 4 out of 5 out of. Now we're at 7. 6 out of, yes? 1 6 6 1. 5 2 2 5.
4 3 4 3.
4 3 3 4, yes? Good, good. So that's 6 out of. So this 8 should be 7.
5.
Except it's not. It's 5.
4.
Because you lose, you can't roll 1 anymore and get 8. It's tempting to want to keep going up. Yeah, you want to go like, okay, so that's, if 7 was 4 3 3 4 2 5 5 2 6 1 1 7, then 8 should be 1 7 7 1, but you like time out, you can't roll a 7 on the die. The max you can roll is a 6.
We're tapped
So-
out. We're gonna go backwards. We're gonna
We
go
have to,
5,
don't we?
4, 3, 2,
We have to, because now we can start using the 6 and 2. We couldn't use 6s down here with the 3s because they were too small, but now we can, but we just can't use the 1 anymore. So when you count these out, you got 8 the hard way, 4 and 4. 6 and 2, 2 and 6.
4 and 4. Or 4. Yeah, 4.
That was over here. What am I missing? 4 and 4. Oh, 5 and 3, 3 and 5. Thank you, there they are. So it's 5 out of. Yes? How about 9s?
4 ways.
That's 6 3 3 6, 5 4 4 5. 10s.
3.
Once again, an odd numerator. 11s. And boxcars,
Only one win.
just as likely as snake eyes. The question is, out of what? We've got the outcomes now. What's it out of?
36.
All those added.
All, Natasha, say that again, nice and loud.
All of those added.
All of those added together. What you've just done, friends, is you've just figured out every single outcome when you throw a pair of dice. You did it all verbally. So they're all accounted for right near the numerators. And when you add all those together, Richie, what do you get?
36.
You get 36. Is there any possible way we could have gotten that 36 way more directly than the way we just did it?
6 times 6.
Say that again!
6 times 6.
Why does that work?
Because there's 6 chances of 20.
Think about it. Natasha, you're saying it perfectly. You're saying it perfectly. Think of your last project. When you start putting probabilities together sequentially, roll a die, now roll a die again. You start multiplying the possibilities. Think about it old school. Okay, suppose this die was a 1. The one in my left hand. Yeah, my left hand is a 1. How many possibilities can this one be over here? 6. It could be a 1 through 6. But that's assuming this one's a 1. What if this one's 2? How many possibilities can this one have?
More.
6 more. How about this one's a 3?
6 more.
4.
6 more.
5.
6 more.
6.
6 more.
What we just did was added 6 times. 6 plus 6 plus 6. But this is why we invented multiplication, because we hate adding like that, yeah? So it's 6 times 6 becomes 36. That wouldn't have helped us figure out the individual outcomes, which we had to do manually by ourselves. Go, go, go.
So I'm gonna gamble with 3 dice. My chances are pretty crappy.
It depends on what you're betting on and what the payouts are. See, now here's a great question. Here's a fantastic question to understand. If I'm going to bet with 3 dice, my chances are pretty crappy. It depends on what you're betting on. Okay? If you're betting on a sum between 3 and 18, I'd say you got pretty good odds.
Yeah.
Right? Nobody's going to give you those bets. But what if you're betting on the average? Okay? Suppose you're betting on the average here. What is the average of
7.
this? It's got to be, doesn't it?
Yeah.
It has to be 7. What's the standard deviation? That's a trickier question, yes? That's a trickier question. Figure it out. Not by hand, but machines. Use your machines to think what's the standard deviation around. Everybody see why the average pretty much has to be 7? It's perfectly symmetric. Right around 7. If it helps, make a graph. I want to turn the machine off. I want to turn the camera off. Fire up the TI. Get a graph of this, and also get the average of the standard deviation. And while we're doing that, we're going to have Excel